demonstration of the laboratory number 6, or a program that will compute a Fourier transform of an input. And let's run the program. For the Dirac delta of t, we will select it first, and then we will push the button to compute for the Fourier transform, and it will show two outputs in different formats. So the Fourier transform of the Dirac delta of t is just 1. Next is for the e raised to negative at times the unit step function, and for this we will need a value for a to set using the slider button, and push the button to compute for the Fourier transform, and the output is 1 over 3 plus wi, or just 1 over, this is a, plus wi, or jw. In the next, we will also need an a value, but our unit step function is in the opposite direction, in the negative t side. So let's use a value of 5 and compute for the Fourier transform. So this is 1 or negative 1 over jw minus 5, or if we simplify, this is just 1 over 5 plus jw, or wi. Next, this is similar to the second one, but there is a t variable. So yeah, let's use 5 again for the a value, and let's compute for the Fourier transform. So this is 1 over 5 plus wi squared, and for the sine and cosine we will need the omega value of 10, and push the button to compute the Fourier transform. So this is pi times the Dirac of w minus 10 minus the Dirac of w plus 10 times negative I, and if you distribute this negative sign, it will just Dirac w plus 10 minus Dirac w minus 10. For the cosine, we will use the omega of 10 and compute for the Fourier transform. So that is the output for the Fourier transform. And for the callback, these two slider buttons have the same code. This is the variable slider val to get the value of this slider num. The tag is slider num, and this should be also in slider num, and it will set the handles of the a value, and this is the a value with the tag a value. The only difference with the other slider is the name of the variables. Instead of slider num, I added 2, and instead of a value, this is wo value, and the last callback is the push button, and these variables will get the value of the radio button, and this a value will get the string of the static text, and the same with the wo value. So for b equals 1, this is for the Dirac delta of t. So using the code Fourier of f, it will get the Fourier transform of the Dirac t, and I have to use character of g to display it on the static text, and this h is for the first static text, and this outstream is for the second static text, which displays the type function, and they just have the same codes for the other radio button, except that the given f is different.